hypothesis testing. So in this video I'll teach you how hypothesis testing. We'll take the past paper questions. So consider the following three independent random samples from a normally distributed population with unknown mean mu, 19.9, 20.4, 20.3 and so on. Okay, 22.3, 16.7 and the data is given to us, and n equals to 15, summation is given in summation x square. Similarly for sample 2 and similarly for sample 3. For sample 2, sample mean and variance is also given to us, and for sample 3 also mean and variance is given to us. Consider the t-test for the hypothesis h0 is equals to mu is equals to 18, whereas h1 is equals to mu is greater than 18. First let's write question 1. And then our hypothesis says h0 is mu backslash mu is equal to 18 and alt equals to h underscore 1 is backslash mu greater than 18. Okay, so this is there. Now part 1a. is calculate the sample mean and variance for the sample 1. For sample 1 we need to calculate mean and variance. So see, for this the value will be obviously alt equals to x bar, and we all know this is backslash summation of xi's divided by n obviously. So this will be, we have our values for summation of xi which is 292.7 and divided by n is 15, which gives us a value of 19.513. okay, this is given to us. Next is what they have told us to calculate is variance. So s square is equals to 1 by 14, which is 1 by n minus 1, 5778. This is given to us in the question, and minus the mean square, 292.7 square divided by 15, which is equals to 4.7955. okay, this we have calculated. Coming to part B of the question. Part B says us carry out a t-test of the stated hypothesis using the sample 1 data, stating the approximate p-value and show that the h0 can be rejected at 1% level of testing. So we need to calculate the test statistic first. We have been given our h0, h1. So therefore test statistic for sample 1 data is equal to x bar minus mu whole into brackets divided by sqrt in brackets s square divided by n, brackets close, space, come out, brackets close, space. okay, follows what? T underscore in brackets n minus 1 distribution. okay, so next line alt equals to, we have our values for, therefore the test statistic is equals to 19, put this in brackets, 19.513 minus 18 divided by sqrt of 4.7955 divided by 15. okay, space, brackets close, space. So this is the value for calculating, to which you get the value of 2.68 coming down. Therefore the p-value is equals to probability of t underscore 14 to be greater than 2.68. okay, so which is just less than 0.01 or 1% level of testing from the tables. Hence we reject H0. Okay, and accept that mu is greater than 18. Okay, at 1% level of testing. Next is part 2. Part 2 says carry out a t-test of the stated hypothesis using the sample 2 data, stating the approximate p-value and the conclusion clearly. So again we have to carry out the t-test now using the sample 2 data. So I am not going to write all of these again, just copy pasting everything and we'll just do the necessary changes. Okay, so this is test for sample 2 data. For sample 2 data we were given the mean, we were given the variance. The mean is 19.867 and the variance is 19.432. Okay, this comes up to 1.64 from here. Now probability T14 greater than 1.64 is between 0.05 and 0.01 and 0.1. So since the value exceeds 5%, hence we cannot reject H0. So mu is equals to 18. Okay, next part B. Part B is just a comment part, I think. Discuss the comparison of results with those based on sample 1, including and for any difference or similarity in the test in the conclusions. So they have said that sample 2 does not provide enough evidence to reject H0. Okay, despite having the same size and a similar mean to sample 1. The reason for loss of significance is much greater variation in the data in sample 2. The variance is very high. The variance is 4 times bigger than in sample 1. Okay, next part coming down. Part 3. Carry out a t-test of the stated hypothesis using the sample 3 data, stating the approximate p-value and your conclusion clearly. Discuss the comparison of results with those based on sample of 1. So again, first we have to carry out for sample 3 and then we have to compare. So for part 3, again this is copied, so I have just pasted. Now for part 3 we have 19.644 minus 18, we have this as 5.2975 divided by 25. Now here this is changed and this becomes to 3.58. Okay, now probability of T24 to be greater than 3.58 is less than 0.000001, which is 0.1%. We reject H0 and accept mu is greater than 18 at a level lower than 0.1% level of testing. Okay, so this is there. Again, for B, the comment we have to write sample 3 even provides stronger evidence against H0 despite having similar mean and variance. The main reason is obviously the sample size. The main reason for much greater level of significance is the increased sample size. Okay, so here we have all of these. This completes our question 1. Coming to next question, which is again a past year question which I have taken. So a researcher obtains 25 items from a normally distributed measurements from 2 factories. Sample variance are 2.86 and 9.21 respectively. Perform a test to determine if the true variances are the same for each factory. Calculate the 95% confidence intervals for the true variances of the measurement and comment on how your answer leads to part 1. So again, first write question 2, coming down. Okay. I'll just focus this for you. So we have this part 1, alt equals to H0 is equals to variances are same, alt equals to H1 is equals to variances are different. You can just write sigma 1 square is equal to and so on. So not all S1 divided by S2 follows F underscore 24 comma 24. So both of these are 24. Therefore the test statistic is equals to 9.21 divided by 2.86, which is equals to 3.22. Okay, F underscore 24 comma 24 comma 0.995 is equal to 0.337, and alt equals to F underscore 24 comma 24 comma 0.005 is equals to 2.967. Since the test statistic is out greater than the critical values or out of the region, we have sufficient evidence to reject H0. Okay, at 1% level of significance. This is how we have done question 2 part 1. Coming down, question 2 part 2, which we'll do, says what? But for each factory outlet, calculate the 95% confidence interval for the true variances of the measurements. We need to calculate the confidence interval for all of these. So we'll calculate CI is n minus 1 s square divided by chi square underscore 0.025 comma n minus 1. Okay, brackets close, space, and comma. I'll not write again anything, I'll just copy this, paste this here, and change this to 0.975. Okay, n minus 1, remove the comma. CI is this. Next, (0.975, 24 is equal to 12 into 12.40, and the next part is 0.025, 24 is 39.36. Okay, therefore CI1 is equals to 1.74, 5.54, and CI2 is equals to 5.61, 17.83. Okay, so these are the two confidence intervals which I need to calculate for each factory. We have calculated. Next is comment on how your answers in part 1 and part 2 relate to each other. So we'll see from part 1 and part 2. Confidence intervals do not overlap. See, this is ekdam different, hence the variances are different from each other. Okay, and here also we have concluded that we have sufficient evidence to reject H0. Okay, so this is how you do your hypothesis testing. Thank you.